Hi, Mike. This is just a quick run through. I thought this would be fun for me to make, and I kind of got into it. So I'm just going to take you through the kinematics crime scene quick. Okay, so here's our first clue that every group is going to get automatically. So if they don't have one person that sees it, they all get to see it. And the key for this one is they need to recognize from the first page that the car is starting at the green light, and when the potted plant lands and breaks the vase, it's like the passenger, it's like the middle of the car. So we have a scale here that's 6 meters. So I can grab one of these and I can say, okay, for the middle of the car to get to there, that's 6 meters. And to get to there, that looks like 12 meters. So it looks like the full scale of 6 meters. Two of those will get the middle of the car from where it starts to where the middle of the car to the broken where the broken vase is, which matches with the pictures we saw before. So that's our first clue that it's 12 meters is the displacement of the car. So we say, okay, car's displacement is 12 meters. That's our first bit of information. The next one is the trail of oil that the car is leaving. We know that each of these dots are 1 second apart. The first big dot is where the car starts, where it was at rest. And this next dot, let me just get out my highlighter here. This next dot right here, that's not a very good color for highlighting. Right here is going to be 1 second away. So I've actually done a calculation for acceleration twice. So this first one right up here, we say, okay, our displacement is if one tick mark is a half meter, because it shows two of the tick marks are 1 meter, this would be 1.5 meters. So we say, okay, the displacement is 1.5 meters and the time is 1 second. I plug that into my kinematics formula and I do some algebra and I come out with the acceleration is 3 meters per second squared. Now I can try that calculation again with the second dot. I can say, okay, I started at the beginning and I end at the second dot. That's a distance of 1, 2, 3, 4, 5, 6 meters. So we put 6 meters in for our displacement, and we're going to solve for our 2 meters in for our time because it's two oil dots. So that would be 2 seconds. So we plug those into our equation and we solve. And again, we find that the acceleration is 3 meters per second squared forward. So that establishes to us that this is constant acceleration at 3 meters per second squared. So now we have our displacement and we have our acceleration from clue two. Looking at clue three, we're looking at the apartment balconies. We notice the lobby is 4.5 meters, and then each floor after that is 3 meters. The balcony will be, the railing on the balcony is 1 meter up. But keep in mind, when we're saying like the third floor, there are two 3 meter floors below the third floor. So here's how we're going to make our equation. We're going to say the displacement is the lobby, which is 4.5 meters. And then instead of saying 3n, because the third floor, you're not actually counting three floors. There's only two 3 meter floors under the third floor. So we would say 3 times n minus 1, and then we have to add the plus 1 for the railing. Now we can simplify all that, and this is going to be our final equation for the height of each floor. Now, if the students don't figure that out, they don't have to actually develop the equation for this. They can just figure out, they can tell how big each floor is, right? So if they have to do it just manually by adding them up, that's not a big deal. They know they're dealing with three different floors from one of the clues, so they're just going to have to figure out which one it is. It's nicer if they can come up with the equation for it. It's more elegant. But if they're just adding numbers, 4.5, and then adding 3 meters each time plus the 1 meter for the balcony or for the railing rather, that's totally fine. If they want to do it, that's a kind of a simpler way. This would be a bit more of an elegant way, but that's what they're going to want to get out of that. You can tell them if they don't get to an equation for that, that's fine, and not a big deal. Clue number four tells us the suspects, and we know that they are on the 8th, 12th, and 16th floors. So that's going to give us some information, right? The previous one could tell us how high each of those floors is. Clue number five has some important stuff which I've already highlighted. The key thing is we know that the car is at rest at the stoplight. We know the car is accelerating constantly. And we know that when the car starts accelerating, that's the same instant when the plant is dropped. So we know that the car driving, the part of where the car drives until the point where it's like in the middle of blocking the view of the potted plant, we know that time is the same amount of time as the potted plant dropping. Okay, so that tells us that those two times are equal. Here's clue number six is the drop test. We can see from the drop test, I don't really know a way to develop an equation for this necessarily. This one's pretty tough, but as long as the students see that each 2 meters per second of increased speed is zero point 0.1 meters of increased like blast radius, I guess it would be. And we know it's zero point 0.9, right? 0.9 meters diameter. So that means we go 0 0.4, 0 0.5, 0 0.6, 0 0.7, 0 0.8, 0 0.9. That's going to give us 18, 20, 22, 24, 26, 28. That's going to give us 28 meters per second is how fast the thing was falling when it hit the ground. 28 meters per second. Okay, that's valuable. So we could say, knowing that it's 28 meters per second, what floor did it fall from? The students will be able to calculate that. If you say final velocity is 28 meters per second, initial velocity is 0 when it gets dropped off the balcony, acceleration is due to gravity, 9.8 meters per second squared, uh, right? How far did it fall? They'll be able to figure that out. So that's one way to figure out which floor they were on. The other way is to do this. So calculate the time for the car to drive from the green light to the vase. This is equal to the time for the potted plant to drop. We already talked about that. The drop time tells us the height that it's dropped from. The height tells us which floor it fell from. And we've got our culprit. Let's go through just a couple calculations the students might do. The car accelerates at 3 meters per second squared. We calculated that. And the initial velocity of the car is 0, starting from rest. So the displacement is 12 meters. And now we've got to find the time. On the left here, I've listed my nose and need to knows. I picked my, let me get my highlighter. I picked my kinematic equation that I'm going to use. I noted that the initial velocity is 0, so I just canceled this whole term out. And then I subbed in my values, 12 for the displacement, and 3 for the acceleration. And I found out that it was root 8. Now you could, like, normally we use decimals in physics class, so the students could write this as like 2.8 whatever. And that's fine, but root 8 just makes it a little simpler because we are going to square that term in the next one. So I just decided to leave it that way. So this is the time for the car to drive. And we know that's equal to the falling potted plant time. So time for the car equals the time for the falling potted plant. Let's calculate how far the plant fell in that amount of time, root 8 seconds. So we list our knows and need to knows. We list our formula. It's the same one again. Initial velocity 0 because you're dropping the potted plant or the potted flowers. We're going to sub in for acceleration is due to gravity, 9.8 meters per second squared, and we're going to sub in our time. We find that the potted plant or the potted thing fell 39.2 meters. So then we say, okay, well, what floor is 39.2 meters up? Students can probably get that just by looking at by thinking about the picture of the floors. I used my equation though, just to make it maybe a little more elegant. So I said, here's my equation that I developed earlier. I'm going to sub in the 39.2 for the displacement, and then I'm going to calculate n. N is 12 and change. So it's the 12th floor. And then we figure out who lives on the 12th floor. We go back to our clue, and there's our culprit on the 12th floor. And hopefully that is the conclusion that students will come to. Okay, I hope that helps. This is fun to do. I've never tried this one before at the class. This is kind of brand new, so sorry for springing it on you. But they're a talented group of young people, and this is not their first crack at kinematics. They did it in grade 11. It's a tricky problem, but I think given some time and churning through, they'll be able to make some great progress, and hopefully this will give you some tips to give them some hints if and when they get stuck. Okay, thanks. Have a good one, and I hope to talk to you soon. Bye for now.